The information contained in this production has been specially formatted for members of the disabled community through funding made available by the GEF Small Grants Program under the project titled Climate Change Training and Capacity Building for NGOs, CBOs, and persons with disabilities.
The State of the Jamaican Climate 2015 Summary for Policymakers. Topic: Incorporating climate information in decision making. Prepared by Climate Studies Group, Mona University of the West Indies, for the Planning Institute of Jamaica. Jamaica. Jamaica is the third largest island in the Caribbean Sea with a total landmass of 10,991 square kilometers. The island is centered on latitude 18 degrees 15 north and longitude 77 degrees 20 west. The island's exclusive economic zone is approximately 25 times the size of its landmass. Jamaica has several rugged mountain ranges, with the highest point, the Blue Mountain Peak, soaring over 2,256 meters. That is 7,402 feet. The coastline is approximately 1,022 kilometers. The climate of Jamaica is mainly tropical, with the most important climatic influences being the northeast trade winds and the island's orographic features, mainly the central ridge of mountains and hills. And that's according to the Jamaica's initial national communication to the United Nations Framework Convention on Climate Change, GOJ 2001. Incorporating climate information in decision making. The report that this document summarizes, the State of the Climate Jamaica 2015 full document, was produced because of a growing recognition that climate data and information specific to Jamaica are required for planning purposes. The State of the Climate Jamaica 2015 full document provides a comprehensive but concise overview of what is known about Jamaica's climate from a survey of available literature complemented by data analysis. The full document is intended as at first, but not last, reference point for Jamaican climate information, particularly for decision makers. But having the information does not mean you know what to do with it. This summary document attempts to provide in a simpler manner a methodology for incorporating the wealth of information provided in the full document in decision making. It does so by summarizing the 3 takeaway messages from the State of the Climate Jamaica 2015 full document under the heading of 4 steps. Within the context of decision making, 4 steps that should guide the incorporation of climate information in decision making are the following. Step 1, take a good look around. Mean patterns of climate provide an initial basis for decision making. Step 2, take a good look again. Trends in present climate must be borne in mind in decision making. Step 3, take a good look ahead. Trends in future climate make the inclusion of climate information a must for decision making. Step 4, take a good look at ourselves. What we know about our climate sensitivity should guide our decision making. Step 1, take a good look around. Mean patterns of climate provide an initial basis for decision making. The first step in factoring climate into decision making is noticing that there are mean spatial and temporal patterns which at the very least must be considered in planning. Mean climate patterns are often referred to as climatologies and are what we expect the climate to be like. Climatologies are found by averaging climate data collected from meteorological stations, provided the data are of sufficient length, example, a couple of decades including the present, and quality, that is, not a lot of data are missing to bias the result. Climatologies are therefore really quantifications using science of how we expect the climate to be behaving yearly. Climatologies establish a baseline for decision making. The mean patterns of climate represent an initial guide which should be used for, among other things, annual resource allocation and spending, contingency and event planning, and as a first guess of the climate bounds for sectors where climate magnitudes and frequencies are significant considerations. Here are 3 climatological patterns relating to temperature, rainfall, and hurricanes respectively that should be considered when climate is being factored into decision making. The information is extracted from the State of the Climate Jamaica 2015 full document. The full document should be consulted for other patterns related to these and other variables that should also be considered. Expect July to be hot. February, maybe not. The temperature climatology across Jamaica is unimodal, with peak temperatures occurring during the summer months from June to September and coolest temperatures occurring around December through March. Figure 5 shows mean maximum and minimum climatologies for 9 stations across the island. The annual range of mean monthly temperatures is small, only about 3 degrees Celsius. Mean island temperatures range between approximately 24 degrees Celsius and 27 degrees Celsius, though mean maximum daytime temperatures can reach as high as 33 degrees Celsius during the warmest months for some locations, while mean minimum nighttime temperatures can be as low as 19 degrees Celsius during coolest months. Jamaica's topography, size, and location allow for some latitudinal and altitudinal variation in mean monthly temperatures. For example, the hilly interior of the island is generally cooler than the coastal plains, and the passage of cold fronts from northern latitudes from October through early April can substantially lower minimum temperatures. It should be noted that there is, in general, less available temperature data than rainfall data for the country. There are 2 rainy seasons and 2 dry ones too. The annual cycle of rainfall for Jamaica, figure 6, indicates a bimodal or 2 peaks pattern. This is the result of an interplay between the large-scale climatic modulators of the intra-Americas. The result is 2 wet seasons, an early rainfall season between April and June, and a late rainfall season between September and November, and 2 dry seasons. The main dry season between December to March, and a midsummer drought in July, early August. Peak rainfall typically occurs in October, and the driest conditions occur in February and March. This pattern of rain is very familiar to farmers in Jamaica and usually forms the basis for when to plant and reap. Interestingly though, this is the mean pattern for Jamaica as a whole. Not everywhere sees this pattern. Jamaica's topography and orientation contributes to different parts of the country receiving different amounts of rainfall and also in shifts in when the peaks occur. For example, The spatial distribution of mean annual rainfall indicates greater amounts in the hilly interior than on the north and south coasts. Rainfall maxima, however, occur in the extreme east and west. Jamaica can be divided into 4 sub-regions based on areas with similar patterns of rainfall variability. The rainfall zones are not defined by parish boundaries. Using station data, these zones are roughly divided, as shown in Figure 8. Each zone has a slightly different mean annual cycle to its rainfall pattern, Figure 9. In Figure 9, the climatology for Jamaica as a whole is also shown for comparison. Note, interestingly, that only 3 of the 4 zones have the bimodal climatology associated with Jamaica as a whole. Table SP1, description of rainfall zones and rainfall patterns. Zone 1, the interior, description that largely encompasses Jamaica's mountainous interior, rainfall pattern. The late season peak and midsummer minimum occur 1 month earlier than for the Jamaica mean in September and June. Zone 2, the east. Description, this incorporates Portland, which records highest rainfall amounts in Jamaica. Rainfall pattern deviates the most from the all-island climatology, with peak rainfall in November and a secondary peak in April to May. Receives most of its rainfall during the traditional dry season. The midsummer minimum occurs in June. The east zone receives the highest amount of rainfall year-round. Zone 3, the west. Description, western Jamaica including the second maximum. Rainfall pattern has the least pronounced midsummer minimum and is one of the wettest zones due to fairly consistent rainfall throughout the year. Zone 4, the coasts. The dry north and south coasts and rainfall pattern, the late season peak and midsummer minimum occur 1 month earlier than for the Jamaica mean in September and June. June too soon. December all over. The North Atlantic hurricane season runs from June 1 to November 30, which coincides with Jamaica's rainfall season. Peak activity in the Atlantic occurs during mid-August to late October, although a deadly hurricane may occur at any time during or right before the season. Table 12 shows the number of storms and hurricanes by category passing within 200 kilometers of Jamaica over the period 1842 to 2016. Tropical storm and hurricane activity in the proximity of Jamaica peaks between August and September, and there is least activity in May and June. Table 12, however, also shows that November is still too early to breathe a sigh of relief. Step 2, take a good look again. Trends in present climate must be borne in mind in decision making. Though looking at the mean state is a good first step for incorporating climate information into decision making, decision makers must go one step further. Even a cursory analysis of the available historical climate data for Jamaica leads to one conclusion: that Jamaican climate is changing. If we can quantify some of the changes we're already seeing, then we shouldn't premise our decision making only on what we expect the climate to be, the climatology. Rather, we must begin to factor in how we already know the climate is varying from the mean. Jamaica's climate data reveals both long-term trends and variations on shorter time scales, which can range from seasonal through decadal. Some of the changes are due to the known global climatic phenomena, example, an El Niño event, while others clearly suggest climate change already at work. For example, rainfall amounts in the dry or wet seasons are strongly conditioned by the occurrence of an El Niño event, roughly every 3 to 7 years, while mean surface temperatures have been steadily rising because of global warming. This means that some of the variations in Jamaica's climate are predictable months in advance, example, those due to El Niño. And there is no reason why they should not already be regularly accounted for in decision making. The State of the Climate, Jamaica 2015 full document provides more information on this kind of variability, seasonal, year to year, and decadal, in addition to pointing to resources that enable forecasting of the climate state to facilitate decision making. Other trends, especially those associated with climate change, are, however, resulting in climate conditions which are different from or at the extreme end of what we are used to seeing or expecting from climatology. Example, the changes in temperature extremes due to global warming. There is a need to know what these trends are, as they represent the unfamiliar and unexpected elements of our present-day climate. They too need to be accounted for in decision-making. Here are 4 present climate trends related to climate change that should be considered when the climate is being factored into decision-making. The full document should also be consulted for other trends related to these and other variables. Yes, it has gotten hotter. Regardless of the data set examined, Jamaica's surface temperature variable shows a steadily increasing trend from the mid-20th century through to the present. Figure 15 illustrates that the warming trend can be found for maximum, minimum, and mean temperatures. Using the crude data set, and for the period 1950 to 2014, minimum temperatures increased at a faster rate, 0.27 degrees Celsius per decade, than maximum temperatures, 0.06 Celsius per decade. This suggests that nighttime temperatures are warming faster than daytime temperatures, and the difference between the two is gradually decreasing. Mean surface temperatures are increasing at a rate of 0.16 degrees Celsius per decade over the same period. Using data for the airport stations, the trend in the mean temperature is estimated at 0.10 degrees Celsius per decade, or 1 degree over the last century. These trends follow the patterns set for the globe and for the Caribbean. The temperature plots also show evidence of variability on decadal timescales and differences from year to year. The linear trend is, however, the most prominent trend. For sure, the rainfall pattern is changing. Unlike temperatures, it is year-to-year variability which is the dominant feature in the Jamaican rainfall record, figure 18. There are strong fluctuations, with one year being very wet compared to the following year, which may be much drier. This is consistent with the fact that there have been a number of recent prolonged droughts recorded for Jamaica, example 2004, 2005, 2009, 2010, and 2014, 2015. Much of the strong interannual year-to-year variation in rainfall can be linked to the El Niño-La Niña phenomenon, which is likely also responsible for the recent increase in rainfall variability seen in the Jamaican record since the late 1990s. In the last 2 decades, there have been at least 8 moderate or strong El Niño 5 and La Niña 3 events. It is this pattern of increased variability in recent years which is of concern and must be borne in mind with respect to planning. in this kind of regime, depending on the climatology for decision making, can have devastating impacts. Information box 4 provides more details on how El Niño is known to affect Caribbean rainfall patterns. In the long term, last 100 years, however, there is no statistically significant linear trend to suggest that Jamaica is getting wetter or drier. There is, however, in addition to significant year-to-year variability, also significant decadal variability. That is, the occurrence of groups of years which are in the mean dry or wet. For example, there is strong indication that Jamaica has been in a wetter phase since the early 2000s. Decadal variability can be linked in part to swings in the phase of the Atlantic Multidecadal Oscillation, AMO. Smooth rainfall anomalies show strong decadal variation in all 4 rainfall zones previously defined. There is a strong correlation for 3 of the zones: the interior, Zone 1, West, Zone 3, and the coasts, Zone 4, suggesting that they are likely influenced by the same large-scale drivers, example, the AMO. Variation in the east, Zone 2, is, however, independent, and its drivers are not fully understood. In the State of the Climate Jamaica 2015 full document, 10 indices representing rainfall extremes were computed using daily station data for 13 stations across the island. The trend suggests the following additional changes with respect to rainfall: increasing trends in annual total wet day precipitation, annual total precipitation on the wettest days, monthly maximum 1- and 5-day precipitation, heavy rainfall events, and the proportion of rainfall intensity to rainfall occurrence. A decreasing trend in the number of consecutive dry days between rainfall events. There is something happening with the hurricanes, but although an increase in Atlantic hurricane activity has been identified since the availability of high-quality satellite data in the early 1980s, there is little consensus that the trend has all been due to climate change. The uncertainty results from the cyclical nature of the other known large-scale modulators of hurricane activity. Example, the role of the Atlantic Multidecadal Oscillation, AMO. The AMO has a positive effect on hurricane frequency and intensity during its warm phases. The AMO swung into a warm phase in the late 1990s. Data also shows that 10 hurricanes and an equal number of tropical storms have passed within 200 kilometers of Jamaica between 1950 and 2015. The distribution of the 10 hurricanes indicates 1 each in the 1960s and 1970s, 2 each in the 1950s and 1980s, and 4 since the 2000s. In general, this corroborates other data, example from the Planning Institute of Jamaica, which has shown that Jamaica has been influenced by more hurricanes and storm events since 2000 than in the 20 preceding years. Yes, sea levels are rising. Global mean sea levels have increased across the globe, with a rate of rise accelerating from 1.7 millimeter year to 3.1 millimeter year through the 20th century due to an increase in global temperatures. Caribbean trends have followed global trends and are currently rising at approximately 2.5 plus 0.4 millimeter over the year. Record high sea level anomalies were observed worldwide in 2015 as a result of a strong El Niño event, including in the Caribbean, where an anomaly increase of 11.3 centimeters above the mean sea level was recorded. Sea levels measured at Port Royal, Jamaica, indicate a similar rate of increase as the globe and were estimated at 1.7 millimeter year using 17 years of data. Satellite altimetry data suggests a similar magnitude rate of increase when averaged over the Jamaican coasts. Sea surface height data, however, remain inconsistent and limited for the coastal regions of Jamaica. Mapping of impacts across the island has shown that sea level rise has contributed significantly to coastal erosion and storm surges, though these studies have not exclusively considered global warming. Step 3, take a good look ahead. Trends in future climate make the inclusion of climate information a must for decision making. When the decisions that are being made carry a generational impact, then future changes in climate trends must also be accounted for. Global and regional climate models run using future scenarios of greenhouse gas emissions provide some consensus about how Jamaica's climate is likely to change in the near future and for time slices through to the end of the century. The models base their projections on a range of future scenarios of greenhouse gas emissions. Chapter 2 of the State of the Climate Jamaica 2015 full document provides details about how future climates are determined, including a discussion on the future greenhouse gas scenarios utilized. Even without 100% certainty about what the future will bring, there are enough consensus from the model simulations to characterize some of the future trends in Jamaican climate. What are striking about the projections are the magnitude, rate, and the frequency of the changes projected in Jamaican climate, especially for the upper range of emissions. Changes in the future climate seem to be quickly, by mid-century, go beyond the present-day bounds of climate variability and signal the emergence of unprecedented new climate norms. This kind of foreknowledge must be used to Jamaica's advantage, that is, by incorporating the future climate information into present-day decision-making. This starts Jamaica on a path toward resilience in the face of climate change. One significant difference to be noted in the 2015 version of the State of the Climate Jamaica is the increased amount of future climate information available at subnational scale. The reader is encouraged to examine Chapter 5 of the full document for detailed summaries. Here are likely trends for the 4 variables previously discussed: temperature, rainfall, sea levels, and hurricanes, which should be taken into account especially for medium to long-term decision-making. It only gets hotter. All available projections indicate a continuation of Jamaica's warming trend into the future. Here are some things to note about the continued warming. The global climate models suggest that the range of the mean surface temperature increase for 4 future scenarios of greenhouse gas increase will be 0.49 degrees Celsius to 0.57 degrees Celsius by the 2020s, 0.85 degrees Celsius to 1.80 degrees Celsius by the 2050s, and 0.82 to 3.09 degrees Celsius for 2081 to 2100, with respect to present day, using a 1986 to 2005 baseline. Similar magnitude changes are projected for maximum and minimum temperatures. For comparison, Jamaica has seen an approximately 1 degree rise in temperature over the last century. The regional climate models, RCMs, which provide sub-country scale information, suggests up to 4.0 degrees Celsius increase for some parts of the island under a high greenhouse gas emission scenario by the end of the century. They also suggest that coastal and eastern regions warm at a slightly slower rate than interior and western regions. August to September to October warms slightly faster than other periods of the year. At the Norman Manley International Airport Station, mean daily maximum temperature each month is expected to increase by 0.8 to 1.3 degrees Celsius and 1.2 to 2.0 degrees Celsius across all future scenarios by early century and mid-century respectively. Warming of daily minimum temperatures is anticipated to be greater, 1.2 to 1.7 degrees Celsius and 1.7 to 3.6 degrees Celsius by early century and mid-century respectively. Similar changes are projected for maximum and minimum temperatures. Statistical downscaling of available station data suggests that the annual frequency of warm days, nights, may increase by 2 to 12 and 4 to 19 days across all future scenarios by early century and mid-century respectively. The annual frequency of cool days, nights in any given month is expected to decrease. In the traditionally cooler month of January to March, the decrease may be up to 6 and 7 days by early century and mid-century respectively. Be prepared for drier times. One of the notable things about the rainfall projections for Jamaica is the emergence of a drying trend which will have established itself by mid-century and which further intensifies by the end of the current century. Here are some things to note about the future rainfall changes for Jamaica from the Global Climate Models GCMs, the Regional Climate Models RCMs, and from the use of statistical downscaling techniques. GCMs project a drying trend as early as the mid-2020s, with 0 to 2% less rainfall in the annual mean. The 2050s may be up to 10% drier, and the end of the century up to 21% drier for the most severe scenarios. The drying trend is primarily driven by a decrease in late wet season rainfall of 1 to 3% by the 2030s and 2 to 20% by the end of the century. There is, in contrast, a minimal increase in rainfall during the dry season, but not enough to offset the late season decrease. RCM projections reflect the onset of a drying trend from the mid-2030s, which continues into the 2050s and through the end of the century. They also suggest spatial variation in the drying across the country, with the south and east showing greater decreases than the north and west for each future time slice. At the Norman Manley International Airport Station, statistical downscaling suggests strong increases in mean daily rainfall for June of up to 57% and 48%, and for December of up to 108% and 68% by the 2020s and 2050s respectively across all future scenarios. Maximum 5-day rainfall may increase for June by up to 65% and 77%, and for December by up to 186% and 155% by early century and mid-century respectively. Decreases for September to October of up 35% are indicated for early century. Maximum dry spell length increases for March by up to 7 and 7 days, and for October by up to 10 and 11 days across all future scenarios by the 2020s and 2050s, respectively. Sea levels will continue to rise. As the temperatures continue to increase, sea levels will continue to rise. A number of recent studies, including by the Intergovernmental Panel on Climate Change, IPCC, indicate a combined upper bound for mean global sea level rise of up to 1.5 meters by the end of the century. Jamaica-specific projections are summarized in Table 56 below and shown for medium sensitivity models in Figure 35. Generally, the difference between north and south coast projections is approximately 0.01 meter, 1 centimeter. By mid-century, the projected largest rise in the mean is 0.39 to 0.40 meter across both coasts. By the end of the century, the projected largest rise in the mean across both coasts is 0.87 to 0.90 meter. Using a multiplication factor, the IPCC suggests that mean sea level rise of 0.5 meter could increase the frequency of sea level extremes by more than 1 order of magnitude, depending on the region. Hurricane strength is likely to increase. 5 major conclusions about future hurricanes under global warming that are of relevance to Jamaica are stated below, as adapted from the IPCC Special Report on Extremes. Supporting arguments for each conclusion can be found in the full document, as well as additional information specific for the Atlantic Basin. Conclusion 1. There is low confidence in projections of changes in tropical cyclone genesis, location, tracks, duration, or areas of impact. Conclusion 2. Based on the level of consistency among models and physical reasoning, it is likely that tropical cyclone-related rainfall rates will increase with greenhouse warming. Conclusion 3. It is likely that the global frequency of tropical cyclones will either decrease or remain essentially unchanged. Conclusion 4. An increase in mean tropical cyclone maximum wind speed is likely, although increases may not occur in all tropical regions. Conclusion 5. While it is likely that overall global frequency will either decrease or remain essentially unchanged, it is more likely than not that the frequency of the most intense storms will increase substantially in some ocean basins. The uncertainty evident in the 5 conclusions suggests that at the very least, Jamaica should contemplate a future where tropical storm hurricane genesis, frequency, and tracks are similar to what has been experienced in the very recent past, last 2 decades. But intensities, rainfall rates, and wind speeds are significantly increased. This is consistent with an increase in the occurrence of higher category storms in the future under climate change. That is, there may not be more storms, but when they do occur, they will be more intense. Step 4. Take a good look at ourselves. What we know about our climate sensitivity should guide our decision making. The final step in factoring climate into decision making is to take a good look at our country and on those things which are premising both development and the future quality of life, on to determine if those possess any sensitivity to climate. Having an understanding of how those things, sectors, important areas of life are already sensitive to climate will allow for the incorporation of climate in the planning for them using steps 1 through 3. Vision 2030 is the national development plan that aims to make Jamaica a first world country by the year 2030. It has 4 national goals, including Goal 4, which aims to see Jamaica having a healthy natural environment and sustainable urban and rural development through the sustainable use of natural resources and hazard risk reduction and adaptation to climate change. There is then already implicit recognition in Jamaica's development plans that climate change presents immense risks. Articulating what those risks may look like will require a better understanding of Jamaica's sensitivity to climate fluctuations and long-term climate change. Jamaica's sensitivity, in part, results from it being a small island developing state, which is dependent on natural resources and climate-sensitive sectors for economic development. The State of the Climate Jamaica 2015 full document provides 14 tables pointing to the climate sensitivity of a number of key economic sectors and important thematic areas identified by Vision 2030 as relevant to the Jamaican way of life and to national development. Summaries of the information provided in the tables are provided below. The reader is encouraged to consult the full document for further details. Table summaries. Development. Climate change is a developmental issue and has the potential to derail Vision 2030 efforts. The persistent and increasing threat of climate impacts, as suggested by projections of increasing temperatures, extreme events, and sea level rise, will severely impact the local economy, workers' productivity, and critical infrastructure located along the coast. In particular, with respect to infrastructural development, Vision 2030 in part premises national development on an expansion and improvement of systems for land transport, including roads, rail and public transport, inland and overseas air transport and service. The continuous development of coastal infrastructure for housing, settlements, and road networks increases the country's vulnerability to the impacts of climate change due to the challenges posed by sea level rise. Education. Vision 2030 promises that every Jamaican child by 2030 will have the best learning environment and leave high school passing 5 CSEC subjects, including English, mathematics, and a foreign language. Climate change may impact the success of these commitments, as extreme temperatures affect concentration and student productivity. More frequent extreme events will further damage school infrastructure, reduce classroom time, and the time needed for guided assistance for success in subjects like mathematics and science subjects. Gender. Gender is a social construct influencing roles and responsibilities of men and women. In Jamaica, women are more vulnerable to climate change than their male counterparts due to their socioeconomic circumstances and the social roles that they are expected to fulfill as women, caregiving and mothering. Security. Vision 2030 promises that by the year 2030, every Jamaican will live in a safe community, and the security forces will have modern and effective ways of maintaining law and order. Climate change is a local national security issue because it exacerbates local vulnerabilities and developmental issues. Climate variables such as increasing temperatures and more frequent storms pose national security threats. This is due to the correlation between increasing temperatures and increased incidents of aggression. Furthermore, More frequent storms may lead to further burdening of the security forces, who will have to increase search and rescue efforts for those communities located in vulnerable areas. Agriculture. Agriculture is one of the most important economic sectors in Jamaica, employing over 180,000 farmers and a 6.8% share in gross domestic product. JAMPRO 2017, RADA 2017. It is also one of the most climate-sensitive sectors. Vision 2030 aims to improve the agricultural sector by increasing the local farmers' productivity by providing access to the best technology and sustaining a healthy natural environment. Projected increases in temperatures and an overall decline in mean rainfall, particularly in the traditional growing seasons, as well as longer drought periods and more frequent extreme events, will result in crop losses and lower productivity. In the Caribbean, livestock is traditionally managed in pastures without water and shade, and in broilers without any cooling aids. Extreme temperatures, droughts, and other climate variables may result in, among other things, heat stress in livestock, resulting in declines in egg, milk, and meat quantity and quality. Marine and terrestrial biodiversity. Vision 2030 reports that by the year 2030, all Jamaicans should live in a healthy and beautiful natural environment with clean air, water, rich forests, and an abundance of plants and animals. This will be achieved by efforts including promoting the use of technologies that will not harm the environment. Climate change in conjunction with poor environmental practices threatens biodiversity. Increasing temperature, sea level rise, and heavy rainfall events will impact on coral reefs, sea turtle nesting, and seagrasses. Poverty. Vision 2030 promises include providing social protection to the most vulnerable and marginalized, including those living in poverty, by ensuring that the government provides these families with opportunities to make a good living and ensuring that welfare and assistance reach the most needy. In 2015, the International Monetary Fund estimated that 20% of Jamaica's population was living in poverty, and that the extensive 2014 drought that continued in 2015 was a contributing factor to limiting poverty reduction prospects. Harsher climate conditions, example extreme temperatures, are likely to affect poorer communities the most, and extreme events are likely to increase incidents of human trafficking within these communities. Tourism. Tourism is a major income earner for the Jamaican economy. At present, Jamaica's tourism brand is predominantly premised on sun, sea, and sand. Vision 2030 envisions that by the year 2030, Jamaica will have a wider choice of tourist attractions in safe and secure resort areas, and that all hotels will be operated in harmony with the natural environment. Climate change will directly impact the tourism sector through impact on tourist arrivals, increased incidence of beach erosion, and through the degradation of both the natural environment and near-shore water quality, example through sargassum events. Tourism infrastructure is also vulnerable to sea level rise and hurricanes, and increasing temperatures will lead to heat-related illnesses among workers and guests, and higher operational costs for cooling aids. Health. Vision 2030 promises a healthcare system that is affordable and accessible to everybody. It also hopes to improve the monitoring and controlling of diseases in the population and ensuring that health services respond quickly to those in need of them. Climate change is likely to impact this commitment, as increasing temperatures may affect the reproductive patterns of both men and women and the emergence of vector-borne diseases. Longer drought conditions and the potential for food insecurity may likely to lead to increased incidence of malnutrition within the population. Society. Jamaican society is inherently vulnerable to the impacts of climate change. Most of the population lives within coastal and mountainous areas and are therefore prone to displacement because of climate impacts such as sea level rise and land slippage. Climatic patterns also continue to guide our work and recreational lives through its impact on key quality of life indicators. Example, health, water availability, and food security. Freshwater resources. Vision 2030 promises to ensure satisfactory water supply and sanitation services by strengthening the systems for storage, treatment, and distribution of water, and proper disposal of wastewater. Water in Jamaica is sourced mainly from groundwater sources, which contribute 84% to local water supply. They are recharged by rainfall. Climate change is likely to affect the delivery of this Vision 2030 commitment because water quality and availability is subject to climatic conditions. Increasing temperature and extreme events will increase evaporation and sedimentation of water. Furthermore, the proximity of basins to the coast is likely to increase saltwater intrusion into local water supply. Energy. Vision 2030 aspires to develop and use new sources of energy such as renewable and natural gas and promote and improve energy conservation and efficiency in government, business, and households. Climate impacts have the potential to challenge this outcome. Energy. Vision 2030 aspires to develop and use new sources of energy such as renewable and natural gas and promote and improve energy conservation and efficiency in government, businesses, and households. Climate impacts have the potential to challenge this outcome. Extreme temperatures will likely increase energy costs for cooling aids, and sea level rise is likely to affect coastal power stations. Storm surges and coastal settlements. Vision 2030 plans to improve design of settlements and facilities to withstand the impacts of climate change. Continued coastal development, which sometimes involves the removal of natural barriers such as mangroves and coral reefs for roads, bridges, and human settlements, increases vulnerability to sea level rise and storm surges. Conclusion. The objective of the State of the Jamaican Climate 2015 report are to 1. Provide current climate information that may be used to inform resilience building efforts at the country and sub-country level, and 2. Allow for improved sector-based assessments for climate resilient planning and decision making. The State of the Jamaican Climate 2015 full document makes it clear that a significant amount of climate information covering present and future climate exists for Jamaica. The lack of any data should not then be the primary excuse for excluding climate information from decisions being made in Jamaica. The summary for policymakers extracts key pieces of information and key messages from the full report and suggests in a stepwise manner how they could be incorporated in an enhanced decision-making framework that incorporates climate. The reader is, however, encouraged to read the full document, which expands on the details provided in this summary. It is also noted that the full document also includes 1. vulnerability profiles for 7 Jamaican communities drawn from the ever-increasing number of studies examining Jamaican communities and their vulnerabilities with respect to climate. And 2, climate resources that are available online. Both chapters 7 and 8 should also be seen as useful resources for decision making. The chapters in the full document are described in the table below. Table SP2, Chapter 1, Rationale and Background and Summary, provides the rationale and describes the structure of the document. Chapter 2, Data and Resources, Summary, a description, data sources, methodologies, and resources used in generating trend profiles for analysis. Chapter 3, Climatology, Summary, an analysis of climate norms for a variety of climate variables as complied from a variety of data sources. An analysis of climate norms for a variety of climate variables as compiled from a variety of data sources. Chapter 4, Observed Variability, Trends and Extremes, description of variability and trends in climate variables based on station and grid data for Jamaica. Chapter 5, Climate Projections, Summary, local and regional projections generated from global climate models, GCMs, and regional climate models, RCMs. Chapter 6, Sector Impacts, Summary, a comprehensive list of climate change impacts on key sectors. Chapter 7, Climate Profiles, a climate vulnerability profile of key geographical areas. Chapter 8, Climate Tools and Resources, Summary, a comprehensive list of useful climate tools and resources for select sectors, and a description of recent record updates. Chapter 9, References, references used in the compiling of the document. Finally, the process of producing the State of the Jamaican Climate 2015 report highlighted some gaps data. These include 1, inadequate climate observation station coverage over the island in general and glaring gaps in, among other places, St. Ann and Portland. 2, the need for more ensembles of regional models run using the RCP scenarios to provide sub-island data. 3, the need for more targeted research on climate impacts on some understudied sectors, including education, the private sector, and biodiversity. And 4, the need for processes to translate the science into real plans and then into actions. One-page summary of climate trends and projections for Jamaica. Historical trend of temperatures. Maximum and mean minimum. These temperatures show upward linear trend. Minimum temperatures are increasing faster, 0.27 degrees Celsius decade, than maximum temperature 0.06 Celsius decade. Mean temperatures increasing at a rate of 0.16 degrees per decade. Increases in temperatures are consistent with global rates, and daily temperature range has decreased. And the projection for temperatures, minimum, maximum, and mean temperatures increase irrespective of scenario through the end of the century. The mean temperature increase in degrees Celsius from the GCMs will be 0.49 degrees Celsius to 0.57 degrees Celsius by the 2020s, 0.65 to 0.84 degrees Celsius by the 2030s, 0.85 degrees Celsius to 1.80 degrees Celsius by the 2050s, and 0.82 to 3.09 degrees Celsius for 2081 to 2100, with respect to a 1986 to 2005 baseline over all 4 RCPs. RCM suggests Higher magnitude increases for the downscaled grid boxes up to 4 degrees Celsius by end of century. Temperature increases across all seasons of the year. Coastal regions show slightly smaller increases than interior regions. Mean daily maximum temperatures each month at the Norman Manley International Airport Station is expected to increase by 0.8 to 1.3 degrees Celsius, that is 1 to 2 to 2.0 degrees Celsius, across all RCPs by early mid-century. The annual frequency of warm days in any given month at the Norman Manley International Airport Station may increase by 2 to 12, 4 to 19 days across all RCPs by early mid-century. Historical trend for rainfall. Significant year-to-year variability due to the influence of phenomenon like the El Niño Southern Oscillation ENSO, insignificant upward trend, strong decadal signal, with wet anomalies in the 1960s, early 1980s, late 1990s, and mid to late 2000s, dry anomalies in the late 1970s, mid and late 1980s, and post-2010. 4 rainfall zones: Interior 1, West 3, and Coasts 4 co-vary on decadal time scale, East least well correlated. Intensity and occurrence of extreme rainfall events increasing between 1940 to 2010. Projection for rainfall. GCM suggests that mid-2020s will see 0 to 2% less rainfall in the annual mean. The 2030s will be up to 4% drier. The 2050s up to 10% drier, while by the end of the century, the country as a whole may be up to 21% drier for the most severe RCP scenario. The GCMs suggest that change in summer rainfall is the primary driver of the drying trend. Dry season rainfall generally shows small increases or no change. RCM projections reflect the onset of a drying trend from the mid-2030s, which continues through to the end of the century. There is some spatial variation across the country, and even within blocks, with the south and east showing greater decreases than the north and west. The decreases are higher for the grid boxes in the RCM than for the GCM projections for the entire country. Historical trend for sea levels. A regional rate of increase of 0.18 plus 0.01 millimeter per year between 1950 and 2010. Higher rate of increase in later years, up to 3.2 millimeter per year between 1993 and 2010. Caribbean sea level changes are near the global mean. SLR at Port Royal, Jamaica, 1.6 millimeter per year. Projections for sea level. For the Caribbean, the combined range for projected SLR spans 0.26 to 0.82 meter by 2100 relative to 1986 to 2005 levels. The range is 0.17 to 0.38 for 2046 to 2065. Other recent studies suggest an upper limit for the Caribbean of up to 1.5 meter under RCP 8.5. For Jamaica, projected SLR over all RCPs for the North Coast is 0.43 to 0.67 meter by the end of the century. Maximum rise is 1.05 meter. SLR rates are similar for the South Coast. Hurricanes. Dramatic increase in frequency and duration of Atlantic hurricanes since 1995. increase in Category 4 and Category 5 hurricanes. Rainfall intensity, associated peak wind intensities, mean rainfall for the same period. And the South is more susceptible to hurricane influence. The projection for hurricanes: no change or slight decrease in frequency of hurricanes. Shift toward stronger storms by the end of the century, as measured by maximum wind speed increases of +2 to +11%. +20% to +30% increase in rainfall rates for the model hurricanes inner core. Smaller increase, 10% at radii of 200 kilometers or larger. An 80% increase in the frequency of Saffir-Simpson, an 80% increase in the frequency of Saffir-Simpson Category 4 and 5 Atlantic hurricanes over the next 80 years using the A1B scenario.